So we want to find the greatest common divisor. We can use prime factorization to determine the greatest common divisor. As the phrase indicates, we want to come up with the largest number or the greatest number that is common to two numbers and will divide both numbers. So you have two numbers and we have to find the greatest number, in other words, the largest number, which will divide both numbers. And that is our objective. Find the greatest, that is what that number is, what we call the greatest common divisor. Now we can use the prime factorization and come up with the greatest common divisor. So the process is quite simple. So for two numbers, write down their prime factorization. Once you have the prime factorization, you have to use it in terms of the, or write it in terms of the exponents. Then you pick the factors with the least powers between the two. So let me start with a simple example. Let's take 18 and 36. Now, clearly, 18 will divide 36, but we've got to come up with the greatest common divisor that will divide both 18 and 36. So 18, I can write it as 2 times 9. 9, I could write it as 3 times 3. So 18 is 2 times 3 times 3, which is 2 times 3 squared. Now we move on to 36. So 36, if I pull 2 out, I will have 18. And we go back to the factorization we already have for 18. So 2, 9, 3, and 3. So 36 can be written as 2 times 2 times 3 times 3, which is 2 squared times 3 squared. So the power of 2 that is smaller in the 2 prime factorizations is 1. And over here, for 3, the powers are equal. So the GCD, or the greatest common factor, must be 2 raised 1 times 3 squared, which is 18. Now, I used the process of prime factorization to come to this conclusion, but the moment I wrote the question, I knew the greatest common divisor would be 18. So why so? You may say, well, why couldn't it be 9? Well, 9 divides 18, great. 18 divides 18 also. 9 divides 36. 18 divides 36. 36 divides 36. So the greatest number that is going to divide 36 is 36. The smallest number is actually 3. Let's not go there. So 9 is in common. So you may argue, well, why can it not be 9? Well, it can't be 9 because 18 is bigger than 9 and it divides both numbers. So the greatest common divisor has to be 18. You may say, well, why can it not be 36? Well, 36 divides 36, but 36 doesn't divide 18. We want to find the GCD using prime factorization. So let's start with 25. The last digit is 5, so 25 is divisible by 5. So I can write it as 5 times 5. But both of them are, well, 5 is prime, so that's the best I could do. So 25 is simply 5 times 5, and that is 5 squared. 70. Want to come up with the smallest prime that would divide 70. We know it ends with 0, so 2 will divide 70. So 2. And I have 35. Now I want to come up with the smallest prime that would divide 35. 5 will divide 35, and I'm going to pick 5 because the last digit is 5. And that will give me 7. So for 70, I have 2 times 5 times 7. If I wrote them, I have 5 squared. 5 times 2 times 7. So 2 is not common to both numbers. Neither is 7. So the only number that is common to both is 5. And one has a power of 2, the other has a power of 1. So what is the smallest exponent? The smallest exponent is 1. So the GCD is 5 raised 1, which is 5. You can always verify the answer. Now you take 5 and divide 25. It will be divisible. Divide 70. 70 will be divisible. So going to start with 96. The smallest prime that is going to divide 96 would be 2. 2 times 48 is 96. Once again, 48 is divisible by 2. 24 times 2 is 48. 24 is divisible by 2. So 2 times 12 is 24. 12 is divisible by 2. 2 times 6 is 12. 6 is divisible by 2. 2 times 3 is 6. And that would be it. So 96 is 2 times 2 times 2 times 2 times 2. which is 2 raised 5 times 3. Let's look at 212. 212, the last digit is 2, which tells us that that number is divisible by 2. So, sorry, it's not 101, it should be 106. Yes. Now 106 is also divisible by 2. So 2, and I've got 53. Now we want to look at 53. Well, is 53 divided, does 2 divide 53? No. Does 3 divide 53? No. Clearly 4 doesn't divide it. Clearly 5 doesn't. Clearly 10 doesn't. 6 doesn't because 2 and 3 do not. 8 doesn't because it doesn't have 3 digits. Clearly 9 doesn't because the digits don't add up to 9. So you may say, well, you've got to try something else. So you can try 7. 7 doesn't divide 53. So there is no reason for me to go past that 7. So I'm going to stop right there. 212 is 2 squared times 53. So 3 is not common to both. 53 is not common to both. The only thing that is common to both is 2, and the smallest exponent is 2. So the answer is 2 squared, which would be 4. Good. So 324, smallest power or smallest prime would be 2, which will give me 162. Smallest prime that divides 162, 2 again. 2 times 81 is 162. 2 is not going to divide 81, so let's go to 3. 3 will divide 81, so I'd have 3 times, 27, which is 81. 3 divides 27, 3 times 9, 27. 3 times 3 is 9. So 324, I can write it as 2 squared times 3 raised 4. 380 can start with 10, but the smallest prime is 2. So I'll go with 190 and 2. Smallest prime is 2 again. So 2 times 95 is 190. 2 doesn't divide 95, neither does 3 or 4. So 5 will divide 95. So 19 times 5. Now 19 is a prime number. So that is the best we could do. So 380 is 2 squared times 5 times 19. Well, as 3 is not common between the two, neither is 5, nor 17. So the only number that is common is 2. So GCD is 2, and its smallest exponent is 2. So the answer is 4.